Hi, I'm Brian, Service Manager at Whole Latte Love, and today we're going to talk about adjusting your brew pressure. Now, today we got a ECM Synchronika with us, and I just wanted to show everyone how to actually adjust your pump. There may be a little bit of confusion as to where you would adjust the pressure on this. Some people that have never used a rotary pump before, used to the vibratory pumps.
They might be used to that thing.
Yeah. This right here is the OPV. There's a couple different styles, but everyone's pretty well aware of this little circular screw on the top here. Generally speaking, on a vibratory pump, you would use this to adjust the overall pressure in your system.
On a rotary pump?
Nope, that's not how that works on this guy. So the sole purpose of the OPV, or sometimes it's used an expansion valve, is to basically just regulate the overall pressure of the hydraulic circuit for the brew boiler. So if you ever adjust this pressure on here, you got to be really careful about what you're doing. There's really not any particular reason to adjust it. The only reason that you may is if for some reason you wanted to have extremely aggressive high pressure profile on your pump. So if you're going up at 10.5, 11 bars of pressure. I personally don't do it, but I fully endorse people doing science stuff. So, you know, however you like to brew your shot. If you want to take it to that extreme, the only thing you got to do is just be careful that you adjust this as well. These are going to come from the manufacturer, adjusted around 11 bars of pressure. It can be a little bit higher, a little bit lower, not more than about a bar though. But if you're going for some sort of aggressive profile like that, you would definitely need to increase this just a little bit, maybe bring it up to 12 bar. I definitely don't suggest going too high with it. It is there for a reason. You know, you don't want to exceed the overall rating of the boiler and risk damaging it or causing any bodily harm. So,
I mean, so that OPV or expansion there on this machine is really kind of a safety device in a way, right?
Exactly, yes. So
where do we really adjust the brew pressure on a rotary pump?
So on the rotary pump, it's going to be right on the pump head. If you look down, I'm just going to swing this out here. Get a little lower view. You can look up straight through that hole there. You should see a slotted screw.
Yep.
That is the adjustment for your pump.
Okay.
Okay. So.
And the procedure for
the procedure for this is, first of all, you need blind portafilter. That in there. Then it's pretty simple actually. So you just lift your lever. You see where your pressure is going to right now. We hit just past 8, about 8.5. So you can do this either with the machine running or you can turn it off. Just got to be careful. The best way to do it is just to let it hang out over the edge like this. You just make sure you're not pulling down on the edge of the machine. You don't want to drop that on yourself. So, you know, even to have someone with you to help hold the machine or something like that, just for safety's sake. But I've done this too many times, so. All you gotta do is get your screwdriver right up in there and start making adjustments.
Okay.
Like I said, you can do this with the machine running, or you can shut it off.
So you're taking a look there.
You want to watch there.
I'm seeing here at 8, less than 8.
There we go.
7.
We're going down, down, down. And it doesn't take a lot. It's just little turns. You have like a quarter of a turn is about a bar. So doesn't take a lot of turning to get it going. Now if you'll see in this, I'll go way up. Way up. There we go. See the water dripping down here?
Yep.
That's my OPV engaging. So that's how I know. If I back it down a little bit, it just starts dripping there.
That was set at right around 11, I think.
Right around 11.
Now, so you set these up, you were saying generally at like 8.5.
Yes, when we bench test these machines before shipping them out, we will send it or set it at 8.5 bars. Now the reason behind that is not because we think that this is the golden pressure or anything like that. The only reason that we do this is just for consistency. If you get your machine and you're noticing an issue with it and say, oh, I think I have low pressure or my pressure's too high, we can say, well, what are you seeing on your gauge? And if you're seeing 8.5, we'll say, no, well, that's actually where we set it to, so that's normal, and maybe we could troubleshoot more from there. But if you're seeing 6 bars or something drastically higher, then we know there's a problem. So that's the main reason that we set it to that pressure.
Now, one other question. We have an additional pressure gauge right up here.
Yes.
And they're not going to be exactly the same, are they?
They are not, no.
And why is that?
Why is that? Good question. So, you'll notice you get up to about where it's set on here, and then it's not always going to happen right away, but this will continue to climb, especially if your boiler is already hot. And the reason behind that is because if you look at the back of the system here, your gauge is right here.
That's where the pressure reading is being taken.
Exactly. Yes. And there's a non-return valve right here before it goes into your boiler. So the pressure that you're going to see on the gauge is just going to be what is coming out of the pump, not what has made it past here and is into the rest of the system.
Okay.
Now, you know, earlier I said overpressure or expansion valve, because you're going to have expansion in the system as the water's running through it, as everything is heating up. You're going to get more pressure in there, and that's why you're going to see increase of pressure on the group gauge if you have a flow control device, as opposed to just having the regular pressure from the pump.
Now, so correct me if I'm wrong, but like this is cooler water being measured back here. It gets to the boiler, it's going to heat up and expand, so it's going to create some pressure, yes?
Yes.
Ah.
So
That's
the reason that you can see a variance between those two gauges.
All right, Brian, thanks so much for taking us through that.
Yeah, not a problem.